Question number 5. Question number 5 in exercise 1.2. Method of finding solutions by using Cramer's rule. Finding solutions by Cramer's rule. Given the market survey, 3 commodities A, B, C were considered according to its consumption of 3 commodities of 3 varieties and also the total weight received. The commodity variety are A, B, C, 3 type. The commodities are A, B, C. In that commodity there are 3 varieties, 1, 2, 3 varieties. The total weight consumption is given as 11, 21, 27. We should find the weight assigned to 3 varieties by Cramer's rule. The weight assigned to 3 varieties by Cramer's rule. To do this, first we should assume the 3 different varieties as X, Y and Z. Let X, Y and Z be 3 varieties respectively. Let X, Y, Z be the varieties 1, 2 and 3 respectively. Now we can form 3 equations by using the data. 1x plus 2y plus 3z equal to 11 total weight. Then 2x plus 4y plus 5z equal to 21. And 3x plus 5y plus 6z equal to 27. There are 3 equations formed by using the given data. That is, let X, Y and Z be the 3 varieties. According to the data, weights of 3 varieties we can include. 3 varieties, that is weight of 3 varieties. According to the data, the first equation will be 1x plus 2y plus 3z equal to 11. The total consumption is 11 given. Therefore, the total value is equal to 11. This is equation number 1. Then, for the second, 2x plus 4y, 2x plus 4y plus 5z equal to 21. And also, one another equation we can form by the data. 3x plus 4y plus 5y plus 6z equal to 27. There are 3 equations formed. Now we have a system of 3 linear equations. We should solve by using Cramer's rule. I have rewritten the equations here. X plus 2y plus 3z equal to 11. 2x plus 4y plus 5z equal to 21. 3x plus 5y plus 6z equal to 27. Now, we should solve by Cramer's rule. How to solve by using Cramer's rule? We should find delta, that should be not equal to 0. Then we should find delta x, delta y, delta z. Then by Cramer's rule, we can find x is equal to delta by delta and y equal to delta y by delta and z equal to delta z by delta. So delta equal to, delta is nothing but determinant of coefficient matrix 1, 2, 3 and 2, 4, 5, 3, 5, 6. Find the value of determinant. 1 into eliminating the first row and first column, calculating the minor value of these 4 elements, 24 minus 25. And then for this one, the purpose of taking cofactor, the sign of these two will change. So minus 2 into the 2 appears second column first row, leaving those column and row. We have 4 elements. Cross multiply, find the value of the determinant. 12 minus 15. 12 minus 15. And then by taking this 3 into these 4 elements are considered. Now 10 minus 12. 10 minus 12. That is equal to 1 into minus 1 minus 2 into minus 3 plus 3 into minus 2, which will be equal to minus 1 plus 6. Again minus 6 is equal to minus 1. So not equal to 0. Delta not equal to 0. Therefore Cramer's rule is applicable. Therefore Cramer's rule is applicable. Cramer's rule is only applicable when delta is not equal to 0. That means the given system of equations has only unique solution. Then delta x. To find delta x, replace the coefficient of x in delta by the constant values. So replace 1, 2, 3 and take the constant values 11, 21, 27. And the remaining 2 columns kept as it is 3, 5, 6. Now expanding with respect to R1, 11 into 24 minus 25 minus 2 into 126 minus 135 plus 3 into 105 minus 3 into 105 minus 108, that will be equal to 11 into minus 1 minus 2 into minus 9 plus 3 into minus 3, that is equal to minus 11 plus 18 minus 9, that is equal to minus 18 delta x is equal to minus 11 plus 18 minus 9 equal to minus 2. Delta y. To find delta y, replace the coefficient of y in delta by the constant values 11, 21, 27. So 11, 21, 27, first and third column as it is remains. Now 1, 2, 3, 3, 5, 6. Again expanding 1 into 21, 5, 27, 6 are taken. 21 into 6, 126. Then 27 into 5, minus 135. And then for this 11, 1, 2, 3, 4, these 4 entries are taken. For the 12 minus 15. And then for this 3, these 4 entries are taken. 2 into 27, 54, minus 3 into 21, minus 63. Now simplify, we have minus 9, 1 into minus 9, minus 11 into minus 3, 1 into minus 9, minus 11 into minus 3 and 3 into minus 9. Multiply, we have minus 9 plus 33 minus 27 equal to minus 3. This is delta y. We should find one another value delta z. Then we can move to the solution. How delta z? Delta z equal to, replace the coefficient of z in delta and by the constants. What are the constants? 11, 21 and 27. Now expanding here. 1 into 4 into 27, 108, minus 5 into 21, 105, minus 2 into 27, 54, minus 3 into 21, 63. And then the third value for 11 plus 11 into 10 minus 12. 10 minus 12. Simplify, we have 1 into 3 minus 2 into minus 9 plus 11 into minus 2, which will be equal to 3 plus 18 minus 22, which is equal to minus 1. So we got a third value delta Z as minus 1. So we found all the four values, delta, delta x, delta y, delta z. Now we can move to the solution. Therefore, by Cramer's rule, the solution x is equal to delta x by delta, x is equal to delta x by delta, that is equal to delta x is minus 2 and delta is minus 1, that is equal to 2. Then for y equal to delta y by delta, that is equal to minus 3 divided by minus 1 equal to 3. And for z, delta z by delta, that is equal to minus 1 by minus 1 equal to 1. Therefore, the solution xy z equal to solution x comma y comma z equal to, therefore the weights of the commodities are 2, 3 and 1. Now question number 6 in exercise 1.2. The given question is, there are 3 amounts invested in an interest earning accounts. 3 amounts invested in 3 interest earning accounts. The total amount is given as 8,500. The total amount is 8,500. The interest rates are 2%, 3% and 6% for a year in simple interest. Totally the interest value is equal to 380 per year is also given. And one more information is given, that is amount invested at 6%. Amount invested at 6% will be equal to sum of other two amounts. Now how much was invested in each account? We should find the value of the amount invested in each account. Okay. First we have to assume, let x, y and z be the amounts invested in 2%, 3% and 6% rate of interest. Let x, y and z be the amount invested in 2%, 3% and 6% accounts. Now, according to the first condition, total value will be equal to 8,500. That means x plus y plus z equal to x plus y plus z equal to 8,500, because These are the three amounts invested. The total value should be equal to 8,500. So sum of these two values is equal to 8,500. So let it be equation number 1. And then by the second data, this is the second data. First data we have completed. Now we are in second data. Second data is interest rates. Simple interest 1 year per year. Interest rates are 2%, 3%, 6%. So total interest is equal to 380. So simple interest means SI equal to PNR by 100. PNR by 100. Principal value for the first case is X. Number of years is 1 year, 1. Into rate of interest is 6 divided by 100, which is equal to 6x by 100. Similar to that, for the second case, for y, it is y into 1 into 3 by 100, that is equal to 3y by 100. And for the third case, z into 1 year into the rate of interest is 6. For the first case it is wrong. For the first case it is 2% only. So 2 here, 2x by 100. Second case is okay. For the third case 6%. So z into 1 into 6 by 100, that is equal to 6z by 100. So these are the interest earned in 1 year. So the total interest value is 380 given. So we should add these three values, then equate to 380, because the interest rates of 2%, 3%, 6% will be equal to total interest will yields 380. So which implies, according to the second condition, we are moving to 2x by 100 plus 3y by 100 plus 6z by 100, which is equal to 380. Now multiply it by 100, we can get 2x plus 3y plus 6z equal to 3800. This is the equation number 2. Now we have one another information. By use of it, we can form a third equation, that is nothing but the amount invested at 6%. The amount invested at 6%. Which is the amount invested in 6%? The Z is the amount invested in 6%. So amount invested in 6% is Z will be equal to, the amount is taken as Z here. Therefore the amount invested in 6% is Z will be equal to sum of the other two amounts. What are the other two amounts? There are three amounts which are taken as X, Y, Z. In 6% we are investing Z amount. The other two amounts are X and Y. So X plus Y. So amount invested at 6% Z equal to is sum of the other two amounts. Sum of other two amounts means X and Y. So Z equal to X plus Y. Now we are moving to third equation, X plus Y minus Z equal to 0. This is the third linear equation. We should solve by using Cramer's rule the three system of equations 1, 2 and 3. I have rewritten the system of equations here. X plus Y plus Z equal to 8500 and 2x plus 3y plus 6z equal to 38,000. X plus Y minus Z equal to 0. Now we should find delta, delta X, delta Y, delta Z. Then we can move to X, Y, Z. Now delta will be equal to determinant of coefficient matrix 1, 1, 1, 2, 3, 6, then 1, 1, minus 1, which is equal to 1 into minus 3 minus 6, again minus 1 into minus 2 minus 6, then plus 1 into 2 minus 1, 1 into 2 minus 3, 2 minus 3, that is equal to 1 into minus 9 minus 1 into minus 8 plus 1 into minus 1, which will be equal to minus 9 plus 8 minus 1, that is equal to minus 2, not equal to 0. Therefore, delta not equal to 0. Cramer's rule applicable. That means the system has unique solution. The system follows unique solution, consistent, and it has unique solution. Okay, now we are moving to delta x. To find delta x, replace the coefficient of x by constant values 8,500, 38,000 and 0. Remaining two columns appear as it is in the first determinant 1, 6, minus 1. Now evaluating this, we can have 8,500 into minus 3 minus 6 minus 1 into minus 38,000 minus 0, and then plus 1 into 38,000 minus 1 into minus 38,000 plus 0. Now 1 into 38,000 minus 0 again. Listen carefully here. 8,500 into minus 3 minus 6. Then this one taken minus 1 into minus 38,000 minus 0. And then for this one, these four entries are taken 38,000 minus 0. Simplify, we have 8,500 into minus 9 minus 1 into minus 38,000 plus 1 into 38,000. Here 8,500 into minus 9, that will be equal to delta x minus 76,500 plus 38,000 plus 38,000. This is totally equal to minus 76,500. Totally we have 76,000. Here subtracting, we will have minus 500. That is equal to delta x. Now you can find two more values, delta y and delta z. Delta y equal to, replacing constants, coefficient of y by constant terms, that is 1, 2, 1, 1, 2, 1, then 8,500, 38,000, 0, then 1, 6, minus 1. That is equal to 1 into minus 38,000 minus 0. Then minus 8,500 into minus 2 minus 6. Minus 2 minus 6. Then plus 1 into 0 minus 38,000. 0 minus 38,000. That is equal to minus 38,000. Here minus 8,500 into minus 8. Again one more minus 38,000. Now adding these two values, we will get minus 76,000. These two are in negative. When multiplying, you get plus 8 into 8,500. That is 68,000, which is equal to minus 68,000. That is equal to minus 8,000. So delta y equal to minus 8,000, and we should find delta z again. Delta z equal to 1, 2, 1, and coefficient of y 1, 3, 1, and replacing constants, coefficient of z by constants here 8,500, 38,000 and 0. Now evaluating this, 1 into 0 minus 38,000 minus 1 into 0 minus 38,000, and then 8,500 into plus 8,500 into 2 minus 3, 2 minus 3, which is equal to minus 38,000 and then plus 38,000 here, plus 8,500 into minus 1, which means minus 8,500. These two get cancelled, which is equal to minus 8,500. We found all the values of delta, delta x, delta y, delta z. We can move to the solution now. The solution x is equal to delta x by delta, that is equal to the delta x value is minus 500 by minus 2. Delta x we found it as minus 500, the delta value is minus 2. Dividing we will get 250. And for the solution of y, delta y by delta, delta y is minus 8,000 and delta value is minus 2. Dividing we will get 4,000. And for z, delta z by delta, delta z value minus 8,500, z value is minus 2. When divide, it implies 4,250 as z. Therefore, the amount invested in each account is 250, 4,000, 4,250. That's all. Next one, example 1.23. The prices of 2 business max books. Next, example 1.23. Given the prices of 3 business max book and 2 accounts book and 1 more commerce book, totally 840, and 2 business max book and 1 accounts book and 1 commerce books, total value equal to 570, and 1 business max book, 1 accounts book and 2 commerce books, total value is 630. We should find the cost of each book by using Cramer's rule. Given the business max book, number of business max book, accounts book and commerce book and its total value, we should find the cost of each book by using Cramer's rule. First of all, assume let x, y, z be the cost of 1 BM book, 1 accounts book and 1 commerce book respectively. By the data, 3 business max book, 2 accounts books and 1 commerce books is equal to 840. Therefore, 3x, 3 business max book, 3 into x, and then 2 accounts book, 2 into y, plus 1 commerce book, 1 is z, equal to total value 840. And then by the second data, we have 2x, business max means x, accounts means y, commerce means z. 2x, 1y plus 1 is z, equal to 570. This is equation number 2. And the third equation is 1 business max book 1x and 1 accounts book 1y and 2 commerce book 2 is z, equal to 630. This is equation number 3. There are 3 linear equations formed. Now we will solve by using Cramer's rule. For that, we should find delta, delta x, delta y and delta z. Then finally we can conclude the answers by x is equal to delta by delta and y equal to delta y by delta and z equal to delta z by delta. Or delta equal to determinant of coefficient matrix 3, 2, 1, then 1, 1, 2, 1, 1, 1, 1, 2. That is equal to 3 into 2 minus 1 minus 2 into 4 minus 1 plus 1 into 2 minus 1. It will be equal to 3 into 1 minus 2 into 3 plus 1 into 1 which is equal to 3 minus 6 plus 1 equal to minus 2, not equal to 0. Therefore, Cramer's rule is applicable. Then delta x, replace the constant coefficient of x by the constant values 840, 570 and 630, 211, 112, that will be equal to 840 into 2 minus 1 and then minus 2 into, or we can choose the column wise, we can expand, that is easy to you by taking 570 minus 570 into, taken these 4 elements, 4 minus 1 and then plus 630 into 2 minus 1. Expanding column wise, it is so easy to calculate. For that I have chosen expanding with respect to C1, 840 into, this 840 appears in the first row and first column. So these 4 elements are taken 2 minus 1 and then taken this element, the cofactor value is changed, therefore minus 570. For this, calculating this determinant, we eliminate the second row and the first column. Then these 4 values are taken, 4 minus 1 and then for 630, this column and row are omitted, so 2 minus 1. This is easy. So therefore 840 into 1 minus 570 into 3 plus 630 into 1. Simplify this, we'll get minus 240, which is equal to minus 240. And delta x. Now delta y, that is equal to, replacing the coefficient of y by constants 321 and then 840, 570, 630, then 112 and then delta z equal to 321, 211, 840, 570, 630. Delta x of 840 into 1 minus 570 into 3, 630 into 1, the total equal to minus 240. And delta y, to calculate delta y, replace the coefficient of y by constants. So 3 to 1 has taken 840, 570, 630, 112. Now expanding this for 3 into 2 into 570 minus 1 into 630, then minus 840 into, now expanding with respect to, here expanded with respect to C1 waves, here C1 waves I have expanded. Again I have chosen R1 waves, expand with respect to R1, will get 3 into 1140 minus 630 minus 840 into 4 minus 1, then plus 1 into 1260 minus 570. Now simplify this one as 510, this one is 3, this one is 690. Simplifying will get minus 300. Similar to that, for delta z, replace the coefficient of z by constants 840, 570 and 630 by expanding with respect to R1 ways. Here also I have chosen R1. Expand with respect to R1, 3 into 630 minus 570 minus 2 into 630, 1260 minus 570, then 840 into 2 minus 1. Simplifying this, we got this is 60 and here 570 and then here 1. So we can have the total sum as minus 360. The value of delta z is 3 into 60 minus 2 into 690 plus 840 into 1. Simplify this, total we have delta z equal to minus 360. Therefore we have the values delta equal to minus 2, delta x is equal to minus 240, delta y equal to minus 300, delta z equal to minus 360. Therefore, the values are x is equal to delta x by delta, which is equal to minus 240 divided by minus 2, that is equal to 120, and y equal to delta y by delta, that is equal to minus 300 divided by minus 2 equal to 150, and delta z equal to delta z by delta, that is equal to minus 360 divided by 2, that is equal to 180. Minus 2 equal to 180. Therefore, the cost of business max book is 120, a business max book, and the cost of one accounts book is 150, and the cost of one commerce book is rupees 180. We are completing 2 exercises now. A small recap, and the areas which are very important are going to discuss here. The first thing is, we learned rank. What is mean rank? It has decided in 2 different ways. Rank means, in determinant method, the non-zero minor of highest order non-zero minor is the rank of the determinant method. That means a 3 by 3 matrix is given, 1 3 by 3 minor, and 9 2 by 2 minors, and 9 1 cross 1 minor will exist. In it, the maximum order non-zero minor is taken as rank. That is in the determinant method. And we move to elementary transformation method after the determinant method. And the elementary transformation method, we are applying some of the elementary transformations. They are very easy to apply. The first one is interchange of rows, and the second one is multiplication of row or column by a non-zero constant, and the third one is addition of row with some other row multiplied by a non-zero constant, or column with some other column multiplied by non-zero constants. Those things are happened in the elementary transformation method while finding rank, right? Then we moved to the application problems, which are only by using elementary transformation by rank method. If the question is given by using rank method, all the 5 marks you should apply only elementary transformation of row transformations. You should not apply for column transformations. While finding rank, you can utilize both column operations and row operations, but while calculating the system of equations by rank method, you should apply only elementary transformations. I have mentioned while doing the sum. Then these are the important areas in the first exercise. The 2 marks will be asked only in rank. 2 marks and 3 marks will appear only in rank, either rank by determinant method or rank by elementary transformation method. No other choices. For 5 mark, it is impossible to get questions from rank. Simply find rank means you can use any one of the method which is familiar to you. Suppose if they mentioned find the rank by determinant method, you should apply only determinant method, otherwise they will not give mark to you. Okay, if they mentioned, you should apply the particular method. If they not mentioned, you can use any one of the method, either determinant method or elementary transformation method, which will be familiar to you. For 5 marks, all the word problems which are taken are considered as 5 marks. That is very important. That means checking the consistency. How to check the consistency? The given system of equations written in the matrix form, and then we can find augmented matrix, that is AB is nothing but combination of the matrix A and B, combined form of A and B, that is augmented matrix. After that we can apply elementary transformations. After applying the elementary transformations, we will be reduce the augmented matrix into equivalent matrix. After some elementary transformations, it will be in the echelon form. After getting the echelon form, we are moving to give the solutions by the result of rank of A equal to rank of AB equal to equal number of unknowns. Equal to 3 means equal number of unknowns. That is n, we can take equal number of unknowns. Equal number of unknowns. The system is consistent and has unique solution. If suppose rank of A is not equal to rank of AB, rank of A is not equal to rank of AB, the system is inconsistent, it has no solution. The first case, rank of A equal to rank of AB equal to given number of unknowns, the system is consistent, has unique solution. The second thing is rank of A is not equal to rank of AB, the system has no solution. And one more solution, one more case exists, that is rank of A equal to rank of AB. Rank of A and rank of AB are equal. Rank of A and rank of AB are equal, but less than number of unknowns. Less than number of unknowns. These type of cases we will have only infinitely many solutions. These type of cases we have only infinitely many solutions. When solving the solution, to get the solution, when solve, we assume a non-zero, we assume a real number for any of the values x, y, z as a solution. Then only we can solve these type of equations. Okay, that is the infinitely many solution case. And those type of problems only will be appeared in 5 marks. Okay, those type of problems will appear in 5 marks. They are very important. Last year board we had one type of question by finding the value of A and B, that example 1.17. so those typical problems are very very important. Repeatedly do practice and get familiar in it. So for 2 marks only, to find the rank will be as, if you familiar, you can use any one of the method. If they mentioned, you use the particular method. That is only for 2 and 3 marks. For 5 marks, checking the consistency of given system of linear equations, or finding the lambda value, or finding the value of A and B, those typical problems are very very important. And then the second thing, we move to second exercise. In that exercise we learned Cramer's rule, how to solve using Cramer's rule. The Cramer's rule is only applicable when the delta is not equal to 0. Delta not equal to 0 only we can apply the Cramer's rule. Otherwise we cannot use the Cramer's rule. Okay, the system of equations gives a unique solution. The delta determined value is non-zero. So the Cramer's rule is applicable to find the unique solution only. In that case, there are 3 things we should find: delta, delta x, delta y, delta z. In delta, only coefficient of the variables are taken. That is the coefficient matrix, determinant of the coefficient matrix A1, A2, A3, B1, B2, B3, C1, C2, C3. A1, B1, C1 are coefficient of, they are the coefficient of x, they are coefficient of y, they are coefficient of z. Like that we will take. So delta means the determinant value of the coefficient matrix. And delta x, to find delta x, replace the coefficients of x in delta by the constants, you can find the determinant value. And then delta y, replace the coefficient of y by the constant value, find determinant value. For delta z, replace the coefficient of z by constant value, find delta z. Then conclude the answer. X is equal to delta x by delta, y equal to delta y by delta, and z equal to delta z by delta. In these typical problems, 2 marks are 2 by 2 equation is given, for example 2x plus 3y equal to 5 and 3x plus 7y equal to 15. These type of equations will be asked in 2 and 3 marks. Solution of system of equations, two unknowns. Solution of system of equations in two unknowns will be only asked in 2 and 3 marks. Then for all the 5 marks, we will get 3 system of equations. 3x plus 2y plus 7z equal to 25. 7z equal to 25 and 4x minus 2y plus 3z equal to 18 and x plus 2y minus 7z equal to 1. Like these type of equations will be given for 5 marks, either solved by Cramer's rule or in the application problems. We have nearly 6-7 application problems in the second exercise, and in first exercise also we have some of 4 plus in the examples also 7 to 8 problems in the examples and exercise in the first exercise also. So both exercises totally we have nearly 15 questions as application problems. Those type of application problems will be asked in 5 marks. So in Cramer's rule, the 3 unknown equations given, it will be 5 marks. 2 unknown equations will be given, that will be 2 mark or 3 mark. Okay. So repeatedly do practice. I have given very clearly and very slowly while working the problems solutions. So you should repeatedly check it and do the examples with the help of the exercise, and then I'll send you a question paper. You will write a test. Okay, thank you to all. And we will have one another exercise, that is a transformation, and we will complete the transformation. The chapter will get over. Before that, you should get familiar in the first 2 exercises, because we have only 4 problems in the exercise of the last exercise and some of the examples. So we will complete within 2 classes, it seems. So we regularly get practice, just repeatedly doing the problems. So this is very important things. Utilize the holidays usefully, then you will be without fear. You will work in the forthcoming classes.